Now, in this lecture, we'll find out the area of the green shape. In the drawing, we have a quarter circle. AOP is a quarter circle. And also, we have tangent QP that is tangent to this quarter circle here at this point. This is angle BQP, that is a right angle. And this angle APQ is also a right angle. In addition, we know that the length of line segment BQ is 3 and AP equals to 6 units in its length. Again, our mission is to find out the area of this green shape. So, first of all, we define the point of tendency of tangent QP with this circle. This point S. And we join points O and S together by a straight line. So, what is the definition of line segment OS? Line segment OS starts from point O, that is the center of the quarter circle, and ends at point S, that is a point on the quarter circle itself. This is exactly the definition of a radius. So OS is the radius of this quarter circle. We define the radius of the quarter circle as x. So the radius OS equals to x. Here we can implement rule 1. We have the radius OS is drawn to point S, that is the point of tendency of tangent QP with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent QP will be perpendicular to the radius SO. If QP is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we'll do a construction, that is to say, from point B, we'll draw perpendicular on OS. Again, from point B, we'll draw perpendicular on the radius OS. So, this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and OS as M. So, in the small quadrilateral BMQS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. So actually, inside quadrilateral PMQS, we have 4 right angles, and therefore, we know that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will write this quadrilateral BMQS as a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, side BQ equals to side MS in rectangle BQ MS. But BQ equals to 3, therefore MS must be also equal to 3 units in its length. So I write it down. ms equals to 3 units in its length. And we also have the rule that the opposite sides of a rectangle are parallel to each other. That is to say, side BQ is parallel to side MS in rectangle BQMS. So I write it down. In rectangle BQMS, side BQ is parallel to side MS. Because again in rectangle BQMS, side BQ is parallel to side MS. MS is part of the radius OS. Again, MS is part of the radius OS. OS is a radius, it is absolutely a straight line. OS is a straight line, and MS is part of the straight line OS. And we know that MS is parallel to BQ, therefore OS, the straight line OS, must be also parallel to BQ. Why? Because if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, OS is also parallel to BQ. OS is parallel to BQ. So, in quadrilateral OBQS, this quadrilateral OBQS, OS, side OS is parallel to side BQ, therefore quadrilateral OBQS is a trapezoid. So I write it down. Quadrilateral OBQS is a trapezoid. Actually, the definition of a trapezoid is a quadrilateral with one pair of parallel lines, of parallel sides. So here in quadrilateral OBQS, side OS is parallel to side BQ, therefore quadrilateral OBQS is a trapezoid. So, what is the length of line segment OM? From the drawing, it is very easy to see that OM equals to OS minus MS. Again, OM equals to OS minus MS. So I write it down. OM equals to OS minus MS. So OM equals to OS, that is X, it is the radius of the circle that is equal to X according to our definition, minus MS. MS is 3, so it is X minus 3. In conclusion, we found out that OM equals to X minus 3 units in its length. This line segment OM so here, this line segment OM is equals to X minus 3 units in its length. In the next step, we will do another construction, that is to say from point A, we will do perpendicular on OS. Again, from point A, we will do perpendicular on OS. this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and OS as N. So in quadrilateral NSPA, in this quadrilateral NSPA, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral NASP, we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be at least a rectangle if not a square, so we will write to quadrilateral NASP as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side AP must be equal to side NS in rectangle ANPS. But AP equals to 6, therefore NS must be also equal to 6 units in its length. So can write down here that the length of this side NS is equals to 6 units in its length. We also know that in rectangle NASP, in this rectangle NASP, the opposite sides are parallel to each other. That is to say, AP is parallel to NS in rectangle APNS. AP is parallel to NS again, AP is parallel to NS in rectangle PNS or NASP. NS is part of the straight line OS. Again, NS is part of the straight line OS. And we know that NS is parallel to AP, therefore OS must be also parallel to AP. Again, OS must be also parallel to AP. According to the rule that if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Here, NS, that is part of the straight line OS, is parallel to AP, therefore the straight line OS itself must be also parallel to AP. Here the straight line OS must be also parallel to AP. Therefore, in quadrilateral OSAP, side OS is parallel to side OP, therefore quadrilateral OSAP is a trapezoid because it has one pair of parallel sides. Side OS is parallel to side AP. So quadrilateral OSPA is a trapezoid. Because it has one pair of parallel sides. In conclusion, we found out actually that this the big shape in total consists of 2 trapezoids. The first trapezoid is trapezoid OBQS and the second trapezoid is trapezoid OSPA. So the sum of the areas of those 2 trapezoids will give us the area of this shape in total, shape OAPQB. Okay. So what is the length of this line segment ON? From the drawing it is very easy to see that ON equals to OS minus NS. Again, ON equals to OS minus NS. So I write it down. ON is equals to OS minus NS. So ON equals to OS is the radius of the quarter circle that is equal to x according to our definition, minus NS. We already found out that NS equals to 6. NS equals to 6. So we already found out that ON equals to x minus 6. ON equals to x minus 6. So this line segment ON is equals to x minus 6 units in its length. In the next step, we focus on the right triangle ONA. On this right triangle ONA. In the right triangle ONA, we define this angle as alpha. Angle NOA equals to alpha in the right triangle ONA. We know that angle BOA, the big angle BOA is the right angle, it is equals to 90 degrees. So the big right angle BOA minus this angle, this is actually angle alpha, must be equal to the missing angle here. Repeat again, the big angle BOA minus this angle, that is angle alpha, equals to the missing angle here, angle BOM. Okay, so the missing angle here equals to 90 degrees minus alpha. Okay, so, and we define 90 degrees minus alpha is beta, and therefore the missing angle here equals to beta. Okay. Here, the sum of those two angles, alpha plus beta, equals to 90 degrees. Why? Because beta equals to 90 degrees minus alpha. 90 degrees minus alpha plus alpha equals to 90 degrees. And we know that angle BOA is indeed a right angle, it is equal to 90 degrees. So in the right triangle OBN, this right triangle OBN, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. Okay, the missing angle here must be equal to 90 degrees minus beta. Here, we know that 90 degrees minus alpha equals to beta according to our definition. From this equation, we will derive that 90 degrees minus beta is equals to alpha. Okay, if you add to this equation alpha and subtract beta, we will get the result that 90 degrees minus beta equals to alpha. So the missing angle here equals to 90 degrees minus beta, and 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. So in the next step, we'll prove that those two right triangles can go into each other. Okay, but before that, what is the definition of line segment OA? Line segment OA starts from point O, that is the center of the quarter circle, and ends at point A, that is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, OA is the radius of this quarter circle, that is equal to x according to our definition. Likewise, what is the definition of line segment OB? Line segment OB starts from point O, that is the center of the quarter circle, and that's at point B, that is the point on the quarter circle itself. Therefore, OB is the radius of this quarter circle, that's equal to x. So in the next step, we'll prove that the right triangle ONA, this right triangle ONA, is congruent to this right triangle OMB. This right triangle OMB. So, why those two right triangles converge to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. So this is angle NOA, in the right triangle ONA, and it is equal to this angle. This is actually angle OBM in the right triangle OMB. Repeat again. Angle ONA in the right triangle ONA equals to angle OBM in the right triangle OMB. They are both equal to alpha, therefore they are equal to each other. In addition, those actually, what is the size of this angle? In the right triangle ONA, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. And according to our definition, 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. So, those two angles, they are both equal to beta, therefore they are equal to each other. So this is angle NAO, in the right triangle ONA, and it is equals to this angle. It is actually angle NOB in the right triangle. It is actually angle MOB in the right triangle OMB. Repeat again. Angle NOA in the right triangle ONA equals to angle MOB in the right triangle OMB. They are both equal to beta, therefore they are equal to each other. And those two angles, they are both equal to 90 degrees, therefore they are equal to each other. Okay, so this is angle ONA. In the right triangle ONA, and this is equals to this angle. This is actually angle OMB in the right triangle OMB. Repeat again. Angle ONA in the right triangle ONA equals to angle OMB in the right triangle OMB. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OA in the right triangle ONA is equal to side OB. Actually, they are both the radii of this quarter circle, therefore they are equal to each other. They are equal to x. Or we can also say that those two sides, they are both equal to x, therefore they are equal to each other. They are both the radii of the circle, therefore they are equal to each other. So, repeat again. Angle OA in the right triangle ONA equals to angle and side OA in the right triangle ONA equals to side OB in the right triangle ONB. They are both the radii of the circle that is equal to x, therefore they are equal to each other. So we actually proved that the right triangle ONA is congruent. This is the sign of congruent to the right triangle ONB according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that the two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that is included between the two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And we proved here that in the right triangle ONA, those two angles alpha and beta, and the side that is included between those two angles, that is side OA, in the right triangle ONA, are correspondingly equal to those two angles that are also alpha and beta, and the side that is included between those two angles, that is side OB, in the right triangle ONB. Therefore, we actually proved that those two right triangles can go into each other according to angle side angle rule. Okay, so and from the fact that those two right triangles can go into each other, we conclude that side ON in the right triangle ONA is equals to side OM side BM in the right triangle OMB. Okay, again, we conclude that side ON in the right triangle ONA is equal to side BM in the right triangle ONB. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two right triangles can go into each other, therefore the two corresponding sides, that is to say side ON and side BM, must be also equal to each other. But we have already found out that OM is equals to OM actually side ON, we already found out that side ON, this is side ON, that is equal to x minus 6. So we can write here that side ON equals to x minus 6. And from this equation, x minus 6 equals to ON equals to BM. We derive that BM is also equal to x minus 6. So this is side BM. This is equals to x minus 6 units in its length. So I write it down. The side BM is equals to x minus 6 units in its length. Likewise, because of the fact that those two right angles can go into each other, we conclude that side AN in the right angle ONA is equal to side AN is equals to side ON to side OM in the right triangle OMB. Repeat again. Side AN in the right triangle ONA equals to side OM in the right triangle OMB. But we have already found out that OM, the length of side OM, is x minus 3. So we can write here that OM equals to x minus 3. And for this equation, AN equals to OM equals to x minus 3, we will derive that AN is also equals to x minus 3 units in its length. So this side AN equals to x minus 3 units in its length. The next step, I'll copy the right triangle ONA, this right triangle ONA in a new page, and we'll implement the Pythagoras theorem on this right triangle, triangle ONA. So actually, this is the right triangle ONA with the coordinates from the original drawing. By PT is the permission for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ONA is OA, therefore the square of the hypotenuse is OA squared. And it is equal to ON squared plus NA squared. OA equals to x, therefore OA squared is x squared. And it is equals to ON squared. ON equals to x minus 6, therefore ON squared is x minus 6 squared plus NA squared. NA equals to x minus 3, therefore NA squared equals to x minus 3 squared. So in conclusion, found out that x squared equals to x minus 6 squared plus x minus 3 squared. Here we'll open the brackets on this side of this equation, and we get that x squared equals to x minus 6 squared equals to x squared plus 6 squared, that is 36, minus 2 times x times 6, that is minus 12x, plus x minus 3 squared equals to x squared, plus 3 squared, that is 9, minus 2 times x times 3, that is minus 6x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancel x squared, in this side of the equation we left with nothing, so it is 0. This is equals to, here we have 36 plus 9 is 45. And we have here minus 12x minus 6x is minus 18x. Plus x squared. So we actually found out that x squared minus 18x plus 45 equals to 0. So this is a quadratic equation, and the normal formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the normal formula. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus the square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, x squared minus 18x plus 45 equals to 0. The coefficient a equals to 1. The coefficient b equals to minus 18. And the coefficient c equals to 45. Now we put the data inside this formula in order to find out the value of x. So x equals to minus b. B is minus 18, therefore minus b is minus 18, that is plus 18, plus minus the square root of b squared. B is minus 18, therefore b squared is minus 18 squared, that is 324, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is 45. So minus 4 times 45 is minus 180, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So x equals to minus 18 plus minus, inside the root we have 324 minus 180, that is 144, divided by 2. So x equals to 18 plus minus the square root of 144 is 12 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 18 plus 12 over 2. 18 plus 12 is 30, and 30 over 2 is 15. So the first solution, x1 equals to 15. And we have also the second solution. According to the second solution, x equals to 18 minus 12 over 2. 18 minus 12 is 6, and 6 over 2 is 3. Because we have found out that according to the second solution, x equals to 3 units in its length. But we already found out that side MB equals to x minus 6 units in its length. Here MB equals to x minus 6. So line segment MB, the length of line segment MB is x minus 6. And because of the fact that MB is a length, it must be a positive number. And so the length x minus 6 must be positive, that is to say it must be greater than 0. If x minus 6 is greater than 0, it means that x is greater than 6. So x must be greater than 6. But x, according to the second solution, x equals to 3, and 3 is less than 6. So this solution is incorrect solution. We cancel the solution, and we have only the second solution that is possible for x. This is actually x equals to 15. X equals to 15. So we actually found out that AO that is equal to x, it is equal to 15 units. OB that is also equals to x, it is equals to 15. Here QS equals to actually x side QS equals to x minus 6, that is actually 15 minus 6, that is 9. SP equals to x minus 3. So x is 15, so 15 minus 3 is 12. Okay, and OS is the radius of the quarter circle, that is equal to 15. So in the next step, because of the fact that this shape consists of two trapezoids, I present to you what is the formula for the area of a trapezoid. Repeat again that a trapezoid is a quadrilateral with one pair of parallel sides. For this trapezoid ABCD, why the shape ABCD is a trapezoid? Because of the fact that side AD is parallel to side BC. Therefore, quadrilateral ABCD is a trapezoid. The two sides AD and BC that are parallel to each other are defined as the bases of this trapezoid. So AD is the base and BC is also the base. And the height is DC because the height creates 90 degrees with the two bases. DC, this angle is equals to 90 degrees and this angle also equals to 90 degrees. So we define the height DC as h. So the area of this trapezoid ABCD is equals to the sum of its bases. So it is, the first base is AD and the second base is BC. So it is AD plus BC times the height. This is the height that is equal to h over 2. Repeat again, the area of a trapezoid is the sum of its bases times the height over 2. Okay. So what is the area of this green shape? The area of the green shape is equals to the area of this shape in total, the whole shape, and this shape consists of two trapezoids. So the first trapezoid is trapezoid OBQS. Plus the area of the second trapezoid OSPA. Repeat again, the area of this shape in total is equals to the area of trapezoid OPQS plus the area of trapezoid OSPA. The area of trapezoid OPQS plus the area of trapezoid OSPA. The sum of the areas of those two trapezoids will give us the area of this shape in total. And then we have to subtract from the area of this shape in total the whole shape, the area of this quarter circle OBA. So it is minus the area of the quarter circle OBA. So repeat again, the area of this green shape is equals to the area of this shape in total, the whole shape, minus the area of this quarter circle OBA. And the area of this, the whole shape, is equals to the area of trapezoid OBQS plus the area of the second trapezoid OSPA. Why? Because this shape consists of those two trapezoids. So the sum of the areas of those two trapezoids will be equal to the area of this whole shape. Repeat again, the area of the green shape equals to the area of the whole shape that consists of two trapezoids. The first trapezoid OBQS plus the second trapezoid OSPA minus the area of this quarter circle, the quarter circle OBA. So what is the area of this trapezoid OBQS? The area of this trapezoid OBQS equals to the sum of its bases, that is PQ plus OS, times the height is QS, divided by 2. Repeat again, the area of trapezoid OBQS equals to the sum of its bases, that is PQ plus OS, times the height QS over 2. The area of trapezoid OBQS equals to PQ plus OS, that is the sum of its bases, times the height, that is QS over 2, plus the area of trapezoid OSPA. What is the area of this trapezoid OSPA? The area of trapezoid OSPA equals to the sum of its bases, that is OS plus AP, times the height is SP, because it creates 90 degrees with the bases here, over 2. Repeat again, the area of trapezoid OSPA equals to OS plus AB, that is the sum of its bases, times the height, that is SP, over 2, minus the area of this quarter circle OBA. The area of this quarter circle OBA equals to the area of the circle over 2. The big circle, actually, the radius of the big circle is x, therefore the area of the big circle will be equal to pi x squared. So the area of the circle is pi x squared, and pi x squared divided by 4 will give us the area of this quarter circle OBA. So what is the area of trapezoid OBQS? The area of trapezoid OBQX equals to PQ, that is 3, plus OS, that is 15, times QS, that is 9, over 2. In conclusion, found out that the area of trapezoid OBQS equals to 3 plus 15 times 9 over 2, plus the area of trapezoid OSPA. What is the area of this trapezoid OBSPA? It is equals to OS, that is 15, plus AP, that is 6, times SP equals to 12, over 2. So the area of trapezoid OSPA equals to 15 plus 6, that is the sum of its bases, times the height, that is 12, over 2, minus the area of the quarter circle OBA. The area of this quarter circle OBA equals to pi times x squared. X is 15, therefore x squared is 15 squared, that is 225, over 4. So the area of the green shape, in total, it will be equal to, here we have 3 plus 15 is 18, and 18 over 2 is 9, and 9 times 9 is 81. So this expression in total equals to 81 square units. It is the area of trapezoid OS, trapezoid OBQS, plus the area of trapezoid OSPA, that is 15 plus 6 is 21, and 12 over 2 is 6, and 21 times 6 is 126. So we found out that the area of trapezoid OSPA is equals to 126 square units, minus the area of the quarter circle OBA, There the quarter circle OBA equals to 225 pi over 4. 225 pi over 4 is equals to 176.716 square units. So there the green shape in total equals to 81 plus 126 is 207, and 207 minus 176.716 is actually equals to 30.285 square units. So in conclusion, we found out that the area of the green shape is equal to 30.285 square units. Repeat again. The area of this green shape is equal to 30.285 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this green shape. So in the drawing, we have a quarter circle, and we also have tangent QP that is tangent to this quarter circle here at this point. This is angle BQP, that is a right angle. This is also angle, this angle is angle APQ, that is also a right angle. Side BQ equals to 4 units in this length, side AP equals to 6 units in this length. Again, our mission is to find out the area of this green shape. So in the first step, we defined the point of tendency of tangent QP with this quarter circle, this point as point S, and then we join points O and S together by a straight line. What is the definition of line segment OS? Line segment OS starts from point O, that is the center of the quarter circle, and ends at point S, that is the point of the quarter circle itself. So this is exactly the definition of a radius. So OS is the radius of this quarter circle. We define the radius of this quarter circle as x. Therefore, OS equals to x. It is the radius of the quarter circle that is equal to x according to our definition. In the next step, we did the construction, that is to say, from point B we do perpendicular on OS. Again, from point B we do perpendicular on OS. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in OS as M. So inside quadrilateral BMQS we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, plus the size of this fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle, this missing fourth angle, must be equal to 90 degrees in its size. So therefore, in quadrilateral BMQS we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we write to this quadrilateral BQMS as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle BQMS, side BQ must be equal to side MS, but BQ equals to 3, therefore MS must be also equal to 3 units in its length. And we have also the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle BQMS, side BQ is parallel to side MS. Repeat again. In rectangle BQMS, side BQ is parallel to side MS. Line segment MS or side MS is part of OS, that is the radius of the quarter circle. The radius, it is absolutely a straight line. So OS is a straight line, and therefore MS is part of the straight line OS and is parallel to BS. If part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Here, part of the straight line OS is, that is MS, is parallel to BQ. Therefore, OS, the straight line OS, must be also parallel to BQ. So here, the straight line OS must be also parallel to BQ. So we actually found out that in quadrilateral OBQS, side OS is parallel to side BQ, therefore quadrilateral OBQS is a trapezoid. Quadrilateral OBQS is a trapezoid because it has one pair of parallel sides. Okay. Then we found out the length of line segment OM. From the drawing it is very easy to see that OM equals to OS minus MS. Again, OM equals to OS minus MS. So OM equals to OS, that is X, it is the radius of the circle, that is X, according to the definition, minus MS, that is 3. So in conclusion, found out that OM equals to X minus 3 units in its length. OM equals to X minus 3 units in its length. In the next step, we did another construction, that is to say, from point A we do perpendicular on OS. Again, from point A we do perpendicular on OS. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and OS as N. So inside quadrilateral ANSP, we have 1, 2, 3 rectangles, therefore this fourth angle must be also equal to 90 degrees according to the rule that the sum of the triangles in any quadrilateral is equal to 360 degrees. So quadrilateral ANSP is 4 rectangles. Any quadrilateral that has 4 rectangles must be at least a rectangle if not a square, so we relate to quadrilateral ANSP as a rectangle. Okay, and we also know that the opposite sides of a rectangle are equal to each other. So side AP must be equal to side NS in rectangle APNS. But AP is 6, therefore NS must be also equal to 6. Here NS equals to 6. And we also know that the opposite sides of a rectangle are parallel to each other. So in rectangle APNS, side AP is parallel to side NS. Repeat again, in rectangle AP and S, side AP is parallel to side NS. So AP is parallel to NS, but NS is part of the straight line OS. Again, NS is part of the straight line OS, and if NS is parallel to AP, then the straight line OS itself must be also parallel to AP. Okay, so OS, the straight line OS, must be also parallel to the straight line AP. So OS must be also parallel to AP. So in quadrilateral OSPA, side OS is parallel to side AP. Therefore, quadrilateral OSPA is a trapezoid, because it has one pair of parallel sides. Quadrilateral OSPA is a trapezoid. In the next step, we focus on the right triangle ONA. On the right triangle ONA, we defined angle NOA. This angle is alpha. angle BOA is equal to 90 degrees. It is a right angle. So the big angle BOA is equal to 90 degrees minus alpha. The big angle minus this angle that is alpha equals to the missing angle. So the missing angle here equals to 90 degrees minus alpha. But according to our definition, 90 degrees minus alpha is beta, therefore the missing angle equals to beta. So in the right triangle OMB, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta is alpha, therefore the missing angle equals to alpha. Likewise, in the right triangle ONA, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, therefore the missing angle equals to beta. In the next step, we proved that the right triangle ONA is congruent to the right triangle OMB. But before that, what is the definition of side OA? Side OA starts from point O and ends at point A. Starts from point O, that is the center of the quarter circle, and ends at point A, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, OA is the radius of the quarter circle, that is equal to x. Likewise, OB is also the radius of the quarter circle, that is equal to x. So in the next step, we proved that the right triangle ONA is congruent to the right triangle OMB. So why those two right triangles congruent to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles are both equal to alpha, therefore they are equal to each other. And finally, those two angles are both equal to beta, therefore they are equal to each other. And also, so all the angles of the right triangle ONA are correspondingly equal to all the angles of the right triangle OBM. In addition, side OA of the right triangle ONA is equal to side OB of the right triangle ONB. They are both the radii of the circle, of the quarter circle, therefore they are equal to each other. So actually proved that those two right triangles can go into each other according to angle side angle rule. What is angle side angle rule? If you prove that two angles and the side that included between the two angles in one triangle are correspondingly equal to two angles and the side that included between the two angles in the second triangle, then you actually proved that the two right triangles, that the two triangles can go into each other according to angle side angle rule. Here we proved that in the right triangle ONA, those two angles alpha and beta and the side that included between those two angles, that is side OA, are correspondingly equal to those two angles that are also alpha and beta, and the side that included between those two angles, that is side OB, in the right triangle OMB. Therefore, we proved actually that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side ON in the right triangle ONA is equal to side BM in the right triangle OBM. Which again, we'll conclude that side ON equals to side BM. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say ON and BM, must be also equal to each other. But we have already found out that ON equals to x minus 6 here. So we can write here that ON equals to x minus 6, and from this equation x minus 6 equals to ON equals to BM, we derive that BM is also equals to x minus 6. if this side BM equals to x minus 6 units in its length. Likewise, from the fact that those two right triangles can go into each other, we will derive that side AN in the right triangle ONA is equals to side OM in the right triangle OBM. AN equals to OM. Again, AN equals to OM, but we already found out that OM equals to x minus 3. So can I write here that OM equals to x minus 3, and from this equation AN equals to OM equals to x minus 3, we will derive that AN is also equals to x minus 3. This is side AN, that is equals to x minus 3 units in its length. In the next step, I copied this right triangle OAN in a new page, and we implemented on this right triangle OAN the Pythagoras theorem. So this is the right triangle ONA that I copied from the original drawing. We already found out that ON equals to x minus 6, AN equals to x minus 3, and OA, the hypotenuse OA, it is equals to x, it is the radius of the quarter circle. So according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse is equals to the sum of the squares of the perpendiculars. So in the right triangle ONA, it means that OA square equals to ON square plus NA square. OA square equals to ON square plus AN square. OA is x, therefore OA square is x square, and it is equals to ON square. ON is x minus 6, therefore ON square is x minus 6 square plus AN square. AN is x minus 3, therefore AN square is x minus 3 square. So in conclusion, found out that x square equals to x minus 6 square plus x minus 3 square. Here we open the brackets on this side of the equation and found out that x square equals to x minus 6 square equals to x square plus 6 squared, that is 36, minus 2 times x times 6, that is minus 12x, plus x minus 3 square, x minus 3 square equals to x square, plus 3 squared, that is 9, minus 2 times x times 3, that is minus 6x. So here we have x square on both sides of the equation, so x square will get cancelled, and after we cancelled x square, in this side of the equation we left with nothing, that is to say, we have here 0, and so in this side of the equation we left with 0, in the other side of the equation we have 36 plus 9 is 45, and we have minus 12x minus 6x is minus 18x, plus x squared. In conclusion, we found out actually that 0 equals to 45 minus 18x plus x squared, or x squared minus 18x plus 45 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Now this specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 18, and the coefficient c equals to 45. So we put this data inside the general equation for x in order to find out the values of x. And found out that x equals to minus b. b is minus 18, therefore minus b is minus 18, that is plus 18, plus minus square root of b squared. b is minus 18, therefore b squared is minus 18 square, that is 325, minus 4 times a is 1, so it is minus 4 times 1, that is minus 4, and minus 4 times c is minus 4, c is 45, so it is minus 4 times 45, that is minus 180, divided by 2a, that is 2. So in conclusion, we found out that x equals to plus 18 plus minus 324 minus 180 is 144 divided by 2. So in conclusion, we found out that x equals to 18 plus minus the square root of 144 is 12 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 18 plus 12 over 2. 18 plus 12 is 30 and 30 over 2 is 15. So according to the first solution, x equals to 15, and we have also another solution that is possible for x. X also could be 18 minus 12, that is 6, and 6 over 2 is 3. So according to the second solution, x equals to 3. But we have already found out that the length of this line segment MB is x minus 6. So MB equals to x minus 6. X minus 6 is a length. As a length, it must be a positive number. So x minus 6 is a positive number. It means that x minus 6 is greater than 0. If x minus 6 is greater than 0, it means that x is greater than 6. So x must be greater than 6. If x must be greater than 6, it can never be equal to 3. So we cancel this solution and we left only with the second solution, with the first solution that is possible for x, that x equals to 15 units in its length. X equals to 15. Then I presented to you the formula for a trapezoid. I repeat again that a trapezoid is a quadrilateral with one pair of parallel lines. In this quadrilateral ABCD, side AD is parallel to side BC. The two parallel sides are defined as the bases of the trapezoid, and the height DC creates 90 degrees with the two bases. Therefore, this is the height that we defined as edge. So the area of this trapezoid ABCD equals to the sum of its bases, that is to say, it is AD plus BC times the height edge, the height DC, that is h. So it is the sum of its bases, that is AD plus BC times the height edge divided by 2. So the area of any trapezoid is equals to the sum of its bases times the height over 2. Okay, so what is the area of this green shape? The area of the green shape equals to the area of this shape in total minus the area of this quarter circle AOB. Repeat again. The area of the green shape equals to the area of this shape in total, the area of the big shape AOPQB, and this shape consists of two trapezoids. So the sum of the areas of the two trapezoids equals to the area of this shape in total. So the area of trapezoid OBQS plus the area of trapezoid OSPA equals to the area of this shape in total minus the area of this quarter circle OBA. Again, the area of this shape in total minus the area of this quarter circle equals to exactly to the area of the green shape. Again, the sum of the areas of the two trapezoids is equal to the area of the shape in total minus the area of the quarter circle LBO equals to the area of the green shape. What is the area of trapezoid OBQS? The area of this trapezoid OBQS equals to the sum of its bases, that is BQ plus OS. BQ plus OS times the height, that is QS, over 2. Again, the area of trapezoid OBQS equals to the sum of its bases, that is BQ plus OS, times the height, that is QS, over 2, plus the area of trapezoid OSPA. What is the area of this trapezoid OSPA? The area of trapezoid OSPA equals to the sum of its bases, that is OS plus AP, to the sum of its bases, that is OS plus AP, times the height, that is SP, times the height, that is SP, over 2, minus the area of the quarter circle. The area of this quarter circle, OBA. The the area of any quarter circle equals to the area of the circle over 4. The radius of the big circle is x, therefore the area of the big circle is pi x squared. And if we divide the area of the circle by 4, we get the area of the quarter circle OBA. So in total, the area of the quarter circle OBA equals to pi x squared over 4. So what is the area of trapezoid OBQS? It is equals to PQ, that is 3, OS is 15, times QS, that is 9 over 2. 3 plus 15 is 18, 18 over 2 is 9, and 9 times 9 is 81. So in conclusion, we found out that the area of trapezoid OBQS is 81 square units, plus the area of trapezoid OSPA. What is the area of trapezoid OSPA? It is equals to OS, that is 15, plus AP, that is 6, times SP, that is 12 over 2. 15 plus 6 is 21, and 21 times 12 over 2, that is 6. 21 times 6 is 126. In conclusion, we found out that the area of trapezoid OSPA is equals to 126 square units, minus the area of the quarter circle ABO. The area of the quarter circle ABO equals to pi x squared. X is 15, therefore x squared is 15 squared, that is 225. Therefore pi x squared over 4 is 225 pi over 4. And 225 pi over 4, it is equals to 176.716 square units. So the area of the quarter circle is equals to 176.716 square units. 81 plus 126 is 207, and 207 minus 176.716 is equals to 30.285 square units. In conclusion, we found out that the area of this green shape is equals to 30.285 square units. Okay, thank you very much.